So you all have to answer, okay? Whenever ma'am is asking something, you all can unmute and answer to ma'am, okay? Otherwise, there's no fun, no? Whatever, whenever ma'am is asking something, you please answer.
Okay, so today we will begin with the topic temperature. All right, but before that, I will ask you all a few questions. You all need to tell me whether I'll pose a few situations before you all. You all need to tell me whether you will feel hot or cold in that situation. Okay, eating an ice cream. Who will say
Cold.
cold? Very good. Okay, sitting near a bonfire.
Hot.
Hot. Hot. Okay. Very good. Very good. Rice being cooked.
Hot.
Rice being cooked. Hot. Okay. Opening a refrigerator.
Cold.
Cold. Yes. Going out on a summer afternoon.
Hot. Hot.
Hot. Okay. Touching a car engine after a drive.
Hot.
Hot. Very good. Visiting a hill station.
Cold.
Cold. Okay. So now I assume that. You all know what is hot and what is cold, right? All of you know what is hot and what is cold?
Yes. Yes.
Yes. Okay. All right. Now, suppose we take a situation in which a person is suffering from fever. Okay. There may be times when you might have suffered from fever. Then, how did you know that you were suffering from fever? How did you know that you were suffering from fever?
Because we'll be hot.
Okay, yes. So your body will be somewhat hotter than other days. Okay, you can sense or feel that your body is really very hot than the other days. So you can know that, okay, or you can come to know that you are suffering from fever. Okay, now suppose your mom keeps a hot glass of milk on the table and you are completely unaware of it. You go and touch the glass and suddenly you withdraw your hands away from it. So, in that case, how will you, when you're withdrawing your hands away from it, it is because the glass is very hot. Okay, you did not know the glass was very hot, but then when you touched it, you felt that the glass was very, very hot. Okay. On the contrary, if you take an ice cream and you touch it, how will it feel? Will it feel hot or cold?
Cold. Cold.
Cold. Okay. But will you feel very comfortable to touch the glass? Sorry, will you feel very comfortable to touch the ice cream? Can you touch it for a very long time?
No.
No.
We can't.
No, we
can't.
Why? Because it will be
Too cold.
Yeah, it will be too cold. Okay, so it will be too cold, so so you cannot touch it for a long time. You will suddenly withdraw your hands away from it as you did for the hot glass of milk. Is that right or not? Okay, in a winter evening, how will you feel? Hot or cold?
Cold. Cold.
Okay.
Cold.
Only if you cover up with a very thick blanket or if you wrap up yourself with a very thick woolen clothes, then you will feel warm. Otherwise, you're going to feel very cold. Why? Because the surrounding air is very cold. Okay? Because the surrounding air is very cold. So you'll feel very cold in winters. Now, from these are extreme situations in which the glass of milk is very hot and the ice cream is very cold. But everything does not have to come in extreme conditions. Okay, like if you place a glass of normal water and you touch it, will that be very hot or very cold?
It will be just fine.
It will be just fine. Okay, it will be normal. Okay, it won't be very hot or it won't be very cold. Okay. Suppose you touch your own body. Now, please feel your own body. Is it very hot or very cold? It's not going to be very hot or it's not going to be very cold. Okay. It's going to be normal because y'all are not, because y'all are not suffering from fever right now. Okay. So, I just wanted to say that our sense of touch can tell us whether an object is hot or cold. It cannot tell us how hot or how cold an object is. Okay? By touching our body, we cannot know how hot or how cold it is. Only we can know, okay, it is hot or it is cold. So, here comes the concept of temperature then. For example, now a temperature will tell us whether a body is how hot or how cold a body is. Okay, temperature is going to tell us how hot or how cold a body is. So temperature can be defined as the hotness or the coldness of an object. Okay, it can be defined as what it can be defined as. Answer? Can anyone answer?
The coldness of an object.
The hotness or the coldness of an object. It is a measure of the hotness or the coldness of an object. Okay. Next slide, please. Now, suppose we are taking the same example again, okay, of fever. Suppose you are suffering from fever and your mom comes and touches you. She feels that your hand is very hot, or she feels your body is hot. What she will suddenly do, she will go and bring the thermometer. She will put it under your tongue and she will try to find out how hot your body is. Okay? Because she already knows that your body is hot. She already felt it. She already touched your body and she knows that your body is hot. But she is trying to find out how hot your body is. Okay? So that is temperature. She is trying to measure the temperature with the help of the thermometer. So we can say that thermometer is an instrument which is used to measure temperature. Okay, it's an instrument which is used to measure the temperature. Have you ever seen a thermometer? Has anyone seen a thermometer? Yes. So can you tell me what type? Okay.
Yes.
Okay.
Yes.
All right. Can anyone tell me what type of thermometers you all have seen?
This one. Thermometer.
Okay, digital one.
Yeah. Digital thermometer.
Okay,
yeah, digital.
Okay, fine. All right. Next slide, please.
Show your future.
So temperature can be actually measured in two scales, okay? That is the Celsius scale and the Fahrenheit scale. Apart from that, there is another scale, that is a Kelvin scale, okay? But we are going to discuss about these two major types of scales, that is the Celsius scale and the Fahrenheit scale. Now, can you tell me in which part of the body should we place the thermometer so that we can actually measure the temperature of our body? In which part of the body can we place the thermometer so that we can measure the temperature of the body?
Under your shoulder.
Under? Okay, that is called the armpits. Very good. Where? I couldn't hear.
Under your arms.
Under your mouth. Or what?
Under your tongue.
Yes, under your tongue. Okay.
Under the hands.
Okay. Under the hands, it is under the armpits. Okay. We can measure temperature by placing it under means in the armpits or under our tongue.
It can also be under. It can also be in our neck, like under
our
neck. Chin. Yeah, under a chin.
Is that so?
Yeah.
Have you ever measured your temperature by placing the thermometer under your chin?
Yeah, I've done that.
Okay, fine. Next slide, please. Okay. Now, As you can see, these thermometers, it's a clinical thermometer. Okay, it is called a clinical thermometer, which we usually use at our homes. Now, when you can see the thermometer, see the left picture. You can see a long line that is 96. Then after that, there is no number mentioned in the other long line. Okay, that is 97. Then after that, the other long line is 98. The other long line will be 90. What will the other long line be?
99.
99. Okay. Then the other long line is 100. So you all came to know about the long lines. You know what numbers are supposed to be there. Now, when we take the divisions in between the lines, actually the first one is called the Fahrenheit scale, and the below one, that is called the Celsius scale. In a clinical thermometer, two types of scales are used. One is the Fahrenheit scale and the other one is the Celsius scale. Okay, first we are discussing about the Fahrenheit scale. Now, between two long lines, how many divisions can you all see? Between two long lines, how many divisions do you all see? How many small divisions do you all see? Can you all see the picture?
10.
Between two long lines, beta, between suppose 96, another one is 97. So between these two long lines, how many lines are you able to see?
4.
4. Very good. Okay, so you are able to see 4 lines.
5.
And 5. You can see 5 lines. Is it 5 or 4?
4. I am able to see 4 lines.
Okay. So there are actually 4 lines in between two big lines. Okay. And each line will be 0.2 degree Fahrenheit. Suppose you take 98. You all can see where 98 is. The long line where it is 98.
Yeah.
Yeah. Then what will be the small division? Suppose the point is after the first small division after 98. So what will be that point? Can you all tell me? First, let me tell you all. It will be 98.2 degree Fahrenheit. Okay. It's going to be 98.2 degree Fahrenheit. The next small division will be 98.4 degree Fahrenheit. There's 0.2 difference, degree Fahrenheit's difference. Then the next small line will be 98.6 degree Fahrenheit. Are you all able to understand how they're taking the measurements? How you can take the measurement?
Yes, ma'am.
How you can measure the temperature? And the following small line will be 98.8. So the first small line will be 98.2. Then after that, it will be 98.4. Then after that, it will be 98.6. After that, it will be 98.8. And finally, the long line will be 99. No 99, no 98.10. Okay, it will be 99. Is that clear to all of you? Are you able to understand? If you all are not able to understand, I'll explain it again.
Yes.
Did everyone understand?
Yes. Yes.
Okay.
Yes, ma'am. Yes.
Okay. Okay, that is all about the Fahrenheit scale. Okay, now if we go to the Celsius scale, now look below the thin tube. Okay, you look below that. There is another scale where it's written 36, 37, 38, 39.
Mama, garam pani આવ ઠંડુ જેવું થઈ ગયું.
Okay, you all can see 4 numbers written: 36, 37, 38, 39. Can you all see, all of you?
Yeah.
Okay.
Yes.
Now 36 and 37, between these two big lines, how many small divisions are there? Between these two big lines, how many small divisions are there? Yes, you all have to count the slightly bigger one too. Okay, so how many small divisions are there? Tell me, who is going to tell me?
Is it 10? 4?
No, it's not 10.
4.
Who can tell me?
8.
You'll have to count all the small lines between 36 and 37.
5.
How
Is
many?
it
9.
5?
It is
Is
9.
it 5?
Very good. It is 9. Okay, you'll have to count between 36 and 37. And I told you all to include the slightly bigger line too. Okay, so y'all will count, that is 4 here and the other 4 that side. And the middle bigger line. So all total 9 lines. Okay, so how will you measure the temperature here then? The first small division will be 36.1. The other one will be 36.2, 36.3, 36.4, 36.5 is the middle bigger line, little slightly bigger one. Then 36.6, 36.7, 36.8, 36.9, and finally it is 37. So there are 9 small divisions between the 2 bigger lines. Clear? Did all of you understand about the Celsius scale?
Yeah.
It is only 0.1 degree Celsius more. Okay, so we can say 36.1 is a small line after 36. When we say point, it means a decimal point. Suppose now the normal body temperature is 98.6 degree Fahrenheit, or we can say it is 37 degrees Celsius. We can say either way, okay? It can be 98.6 degree Fahrenheit, or it can be 37 degrees Celsius. Now, what is this point? It is a decimal point, and it shows that 98.6 is a number that comes after 98 and before 99. So it is a number which is bigger than 98 but smaller than 99. Okay? Is that clear to all of you? Have all of you understood? Okay.
Yes.
Next slide, please.
Yes. Yes.
Now we'll discuss some history about the
Yes.
thermometer. Okay. Now, the first invented thermometer was called thermoscope. Okay. And in 1593, Galileo Galilei, he invented a water thermometer. How does a water thermometer work? Suppose water is boiled in a saucepan, okay, and you cover it with a lid. What will happen after some time? The water will rise up and it will exert some force on the lid, due to which the lid will shake a little. So in the same way, a water thermometer works. Okay, if you put a water thermometer in a hot object, the water will rise up to show us that the object is hot. And if you take it out of the hot object, then the water level will go down. Okay, the water level is going to go down. In 1612, Santorio, he invented a numerical scale. What's a numerical scale? Nowadays, as we discussed now before, okay, that's the Celsius scale and the Fahrenheit scale. So that scale was invented by Santorio in the year 1612. Okay, and in 1714, Gabriel Fahrenheit, he invented the first mercury thermometer. Nowadays, we also use the mercury thermometers at our homes. Okay, so the mercury thermometer was invented by Gabriel Fahrenheit. He invented it. All right, next slide, please. Okay. Now, we'll perform an experiment. Next slide.
Okay.
Okay. Before that, let us know about the types of thermometers. Okay, the different types. Now, you all know about the digital thermometer. Majority of you all have the digital thermometer, right? You all might have seen it. Look at a clinical thermometer. Okay, this is the picture of a clinical thermometer. And infrared digital thermometer. These three thermometers are actually, they are made to measure the human body temperature. These three thermometers are meant to measure the human body temperature. Okay, they cannot measure any other thing except the human body temperature. And the one that is on the top, that is called a lab thermometer. Now the lab thermometer can be used to measure any other object, okay, in the lab. Like you, if you want to measure the temperature of boiling water, then you can measure it with a lab thermometer. If you want to measure the, the temperature of chilled water, then you can measure it with a lab thermometer. If you want to measure any other thing, the temperature of any other liquid, okay, then you can measure it with a lab thermometer. But you cannot use these three kinds of thermometers for measuring any other thing except human body temperature. It is purely meant for human body temperature. Okay, because and the range is also very low in case of the clinical thermometer. So we can only measure human body temperature, because if we try to measure something else, that scale is not there in the clinical thermometer, or the digital thermometer also cannot take that much of heat. It cannot show the temperature of that much of heat, because it is only designed for the human body. Okay. Next slide, please. Okay. Here we'll discuss about, the two types of thermometers. I'll show you all the two types of thermometers here. Okay, this is it visible to all of you? The thermometer is visible? Hello?
Not well, not clearly.
Okay, not clearly. You all do not know about the divisions, but can you see it?
Yes.
Can you see this thermometer?
Yes. Yes.
Yes.
Okay. So this is a clinical thermometer. Okay. This is called a clinical thermometer. And it's very small, you all can see. And this is a lab thermometer. All right. It is comparatively longer than the clinical thermometer. All right. This portion which you see, this portion, okay, it is called the bulb of the thermometer. Can you all see it? Can you all see this portion? Okay. So this is called the bulb of the thermometer. Okay. And there runs a thin tube in the center. There runs a thin tube, very thin tube in the center. That is called the capillary tube. All right. Now, this is in the same way, in this thermometer also, there is a thin tube at the center. That is called the capillary tube. Now, this is having a liquid called the mercury. The clinical thermometer is having a liquid called mercury. Okay. The mercury is silver in color. And the lab thermometer is having a liquid which is red in color. You can see it. It's red in color. It is alcohol. Is it visible?
Yes, ma'am.
Okay. It is alcohol. Okay. Now, we'll look at the slide which tries to differentiate between the clinical and lab thermometers. Okay, so the length of the clinical thermometer is 11.3 centimeter. Okay, it's very small. And the lab thermometer is 29.7 centimeter. It's longer than the clinical thermometer. You saw it? Okay. Now, the range of temperature in a clinical thermometer will be 35 to 42 degrees Celsius. Okay, let us discuss the major points. What is the color of liquid inside the clinical thermometer? I showed you the color of the liquid. What is the color? It is which color? In a clinical thermometer, in the small thermometer, what is the color? Can anyone tell me?
Red.
Red was in the big
Silver.
thermometer.
Silver.
Silver. Very good.
Silver.
Okay. So silver. And what is that liquid called?
Mercury.
The mercury. Very good.
Mercury.
Okay. And the big thermometer, what is it known as? It is known as which thermometer? The big thermometer is known as?
Lab thermometer.
Lab thermometer. Okay.
Thermometer.
What is the color of the liquid inside the lab thermometer?
Red.
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 Okay. And what is the name of the liquid? Can anyone tell me what is the name of the liquid
Alcohol.
in the lab thermometer? Alcohol.
Alcohol.
Okay. So these are actually the main. And one more very important difference is that in the clinical thermometer, we have two scales. As we discussed earlier, that there is a Celsius scale and there is also Fahrenheit scale. But in the lab thermometer, there is only one scale, that is the Celsius scale. Okay? We have only one scale in the lab thermometer, that is Celsius scale. And in the clinical thermometer, we have two scales, that is Celsius and the Fahrenheit scale. Okay? One more very important thing in the clinical thermometer is there is a small constriction, which is known as a kink. Okay? This kink does not allow the mercury to, move down. Okay? Suppose you put the clinical thermometer in your mouth, then after that, when you take it out, no heat is means it is not in contact of a hot body, so the mercury level will come down. But what happens? There is a small constriction which does not allow the mercury level to fall down. Okay? That is called the kink. You can see it in the picture. Okay? But a kink is not present in a lab thermometer. It is only present in a clinical thermometer. All right? So these are some of the major differences between the clinical thermometer and the lab thermometer. And all these thermometers are actually clinical. Okay? We are using it to measure human body temperature. So it is a clinical thermometer. These are all types of clinical thermometer, or we can the digital thermometer or the infrared thermometer. The infrared thermometer, it is how does it measure the temperature? It does not have to touch the hot body. From a distance only, some rays come out and then it measures the temperature of the body. Okay. During this pandemic situation, like during COVID-19, we should not touch others, okay, because there is a chance of infection. So you can measure the temperature, with this infrared thermometer, okay. And digital thermometer, all of you know how to use it. You all have to put it below your tongue. The bulb has to be put. This part has to be put below your tongue or in your or under, or we can say the armpits, and it can be measured. Is that clear to all of you all? Means digitally, we don't have to measure anything in the scale. The number will appear on the screen. Okay. Next slide, please. Okay. Now I'll tell you all how to use a thermometer. Okay. First of all, suppose this is the clinical thermometer. I will take the thermometer, I will wash it with an antiseptic solution. I'm going to wash it with an antiseptic solution. Why am I going to wash it with an antiseptic solution? So that this thermometer is disinfected. Disinfected means it is free of germs. Okay? Then what I have to do, I have to, jerk it 2 to 3 times. Why am I going to do that? So that the level of mercury falls below 35 degrees Celsius. So that the level of mercury is there in this capillary tube. The level of the mercury will fall below 35 degrees Celsius. Okay. Then what I will do, I will put it below my tongue. I will keep it there for 2 minutes. After that, I'll remove it out and I'll put it straight along my line of sight and I'll see what is the temperature, okay, according to the scale. Because when mercury touches a hot object, the mercury expands and it moves up in the capillary tube. When it moves up, then I can see what is the measurement, what is the temperature of my body. Can you do it if anyone is ill? Can you do it yourself? Can anyone tell me the procedure, what you all must follow again, or shall I explain it again? What we must do first? Can anyone tell me what we must do first?
First, wash it. You have to dip it in
Okay,
antiseptic.
first wash it. Yeah, very good. First, you must wash it with an antiseptic solution. Why? Why must we wash it with an antiseptic solution? So that
To fight germs.
okay, so that it gets disinfected or the germs are killed. All right, then what we have to do? Then what is the second step? Yeah, we have to jerk it. And why is that done? Why is that done? Can you all tell me? So that the level of the mercury drops down below 35 degrees Celsius. Okay? Below 35 degrees Celsius, the level of the mercury drops down. Therefore, we need to shake it so that if the level of mercury does not fall below 35 degrees Celsius, we cannot measure our body temperature accurately. Okay? We have to jerk it twice or thrice so that the mercury level, drops down. And then we can take an accurate measurement of our body or accurate temperature measurement of our body. Okay, then what we must do after that? After jerking it?
Put it in your underneath your tongue.
Okay, put it underneath your tongue. How many minutes are you supposed to keep it?
2 minutes.
2 minutes.
2 minutes. Very good. Then after that, what you're supposed to do? After that, what you're supposed to do?
Take it out and show it.
Take it out and see
Show
it. Okay. And how will it be kept, like this or like this? The first one or the second one? How is it going to be seen?
Second.
Second one. We should see it. It should be kept horizontally to our line of sight so that we can see it clearly. Okay. And then we have to measure our temperature, or we can see the temperature. What is the temperature of our body? Did you follow this? Now there are some more safety measures that you'll have to follow. You all should not keep the clinical thermometer in the sun, because what will happen then? It might break, because the clinical thermometer cannot measure so much of temperature. It can break in that case. This is made up of glass, so it can break in that case. Okay. And we must not hold the bulb anytime. We should always hold the glass portion. Okay. So these are some of the things that we must follow. And we must not, measure any other thing except human body temperature. We should only measure human body temperature with the help of the clinical thermometer or digital thermometer or the infrared thermometer. We should use it only to measure human body temperature. We cannot use it to measure any other thing. Clear?
Okay.
Yeah. Because if we use it to measure any other thing, this temperature is not meant for that much of heat or that much of cold. Okay, it cannot take it, so it might break. Next slide. Okay, this is how you must take a look, and you can read the temperature on your thermometer. Okay, this is how when it comes in contact with a hot object, then the level of the mercury rises. Okay, there are some things that you must remember, that water always boils at 100 degrees Celsius. What is the boiling point of water? It is 100 degrees Celsius. Okay, and the temperature at which water becomes ice is 0 degrees Celsius. All right, it is 0 degree Celsius. What is there are four things that you all must remember. One is the boiling point of water, that is 100 degrees Celsius. The freezing point of water means when the water gets converted into ice, that is 0 degrees Celsius. Okay, the normal body temperature, our normal body temperature is 37 degrees Celsius. Okay, and room temperature is 20 degrees Celsius, or sometimes it may vary a little bit. Okay, so the boiling point of water, the freezing point of water, and the normal body temperature is can be asked as a question. Okay, tell me, what is the boiling point of water?
100 degrees.
100 degrees
Okay,
Celsius.
100 degrees Celsius. You all have to mention the unit, okay? Because if you all do not mention the unit, it's going to be wrong. It can be 100 degree Fahrenheit. Anyone can think anything, okay? So you all have to mention the unit with it. What is the freezing point of water?
0 degrees Celsius.
0 degree Celsius. Okay.
0 degrees Celsius.
What is the normal human body temperature?
37 degrees
What's the
Celsius.
normal human body temperature?
37 degrees
37.
37.
Okay, that's very good. Okay. Next slide, please. Now, what you all will do, all of you all are having a digital thermometer. Is everyone having a digital thermometer with you all now?
Yes.
Yes.
Yes. Yes. Yes.
Okay, fine. Now, what you all will do, you all will measure y'all's body temperature with the digital thermometer. Okay? First of all, what you'll have to do, you'll have to wash it. Okay? You all need not jerk it. It is not a clinical thermometer that the mercury level will drop down. You all need not jerk it. You all will only wash it under water. Okay? And you all will not hold the bulb. You all will put it below your tongue. Keep it there for some minutes until a beep sound comes. And then after that, take it out and tell me what is the temperature on your digital thermometer. Okay. All of y'all are supposed to do it. Okay? Y'all will do it right now. And y'all will tell me. All of you start doing it.
It's 98 Fahrenheit.
It is?
98.
What is? Okay, it is
97
98.
Fahrenheit.
97 Fahrenheit.
Okay, very close. Okay, very close to 98.6 degree Fahrenheit. So all of your body temperature need not be the same. Okay, it may vary a little. So all of you got it? All of you are able to measure your own body temperature? Have all of you all done it?
6.2.
Yes. 97.1 Fahrenheit.
Okay. Who else is left to do it?
30.
99. Yes. 99.2 Fahrenheit.
99.
99.
Okay, 99.
Fahrenheit.
Okay, 99. 99 degree Fahrenheit. Okay, we must always mention, whenever we are mentioning Fahrenheit, we must always say degree Fahrenheit. Okay. Yeah. Anyone else who has measured it? Okay, all of you have done it?
Yes. Yes, ma'am.
Yes, ma'am.
All right. So you all are able to measure your own body temperature. Okay. If anybody is having fever, you all can measure it for them, or you all can measure their body temperature, or you all need to depend on mama or papa for it.
No.
You all can do it yourself, right?
Yeah.
Okay, fine. Okay, we can see the slide now. Yeah. So all of you are able to, measure your body temperature. Okay. So nowadays, what is used? Nowadays, digital thermometers are used. It is the modified version. Okay. Previously means before clinical thermometers were used, in which mercury was used. Okay. But mercury is poisonous for us. It can be toxic. If this thermometer breaks, the mercury can come out of it and it can be poisonous for us. So nowadays we use digital thermometers. Okay. So that there is no such danger in that case. Next slide.
Okay.
Now we'll conduct another experiment. Okay. You all are having 3 containers or 3 beakers with you all.
Yes.
Yes.
Okay. All of you all bring the 3 beakers, and what I will do, I will show you all what you all need to do. Can you all see it? Is it visible? The 3 beakers, are they visible?
Yeah, ma'am.
Ma'am,
I
I have only two. One is small.
Okay, one.
Yes.
Okay,
Only 2
wait.
are visible.
You can move it to your right.
Okay, what you'll have to do, in one, you'll have to take cold water. Okay? 3 beakers you'll need to take. In one, you'll have to take cold water. In the other one, you'll have to take hot water. And in this, you'll have to mix both the waters. Okay? Hot water and cold water. So you'll do that. All of you'll do that. In one, take cold water. In the other, you'll take hot water. If not hot, it can be warm. Okay? Doesn't matter. And the third one, y'all can take a mixture of hot and cold water.
Adjust your camera so that we can see the experiment. don't worry if it's not a beaker. It can be any container. It can be a katori. It can be a glass. It can be anything.
Yeah.
उल्टा कैसे करना है कैमरा?
All of you have arranged the 3 beakers with cold water, hot water, and normal water.
Yes.
Okay.
Yes.
All ready for the experiment now?
No, ma'am.
Okay. First, what you all will do, you all will put your left hand in the first beaker. Put your left hand in the first beaker. How does it feel?
Cold.
Cold. How does it feel, everyone?
Cold. Hot. Hot.
Okay. Those who have put hot water, it is hot, and those who have put cold water, it is cold, right? Now you'll put your right hand in the second beaker.
Ma'am, I'm still filling the water.
Okay, okay, we'll wait. We can wait, okay?
Cold.
Okay. Can we start now? Can we start, everyone? Are you ready?
Yes.
Everyone is ready?
Yes.
Okay. So we can put our left hand in the first beaker. What will we feel? It is cold. Since I have taken cold water, it is cold. Okay. Whatever you all have taken, you all will feel the same.
Warm.
Tell me how do you all feel when you all put your left hand in the first beaker?
Cold. Cold.
Cold. Cold. You all put your right hand in the second beaker. What do you all feel?
Warm.
Cold.
Cold.
Hot.
Hot. Okay. If you have taken hot water, you will feel it hot, and if you have taken cold water in beaker 2, you will feel it cold. Now what you all do, you all take out both the hands from both the beakers and put it together in this water, which is normal water. And tell me, how do you all feel? Put it together.
Normal. Normal.
Just like
Normal.
How do you all feel? Is it the same in both the
Normal.
hands? Is it the same in both the hands?
yes. Yes.
It is the same in both the hands. You feel normal.
No. In
How do
one
you
it's
feel? Can you all tell me?
feeling hot.
One is little hot and one is little
Cold.
cold. Yes. Okay. Now what you all will do you have a paper beside you all?
No. No.
No. Okay. Can you all bring a paper? A piece of
Yes.
paper?
Yes.
When you put your hand in the first beaker, if it is hot, it will be slightly more than the body temperature. Tell me, what is the human body temperature, normal human body temperature? What's the normal human body temperature?
37
37.
98.6.
If the, okay, 98.6 degree Fahrenheit. Okay, so we measure it in Fahrenheit. So it is 98.6 degree Fahrenheit, the normal human body temperature. If it is cold, then what do you think? The temperature will rise or will it come down?
Come down.
Come down. So all of you, guess, what can be the temperature of the cold water?
0
first-
degree.
And if it is hot, then it will be more than the human body temperature. It will rise. Okay. So you all can just do a guesswork. You all can guess what will be the temperature of the cold water that is in beaker A or beaker. In the first beaker, if it is cold water, you all can guess the temperature, and if it is hot also, you all can guess the temperature. Just write anything guessing it, because if it is cold water, it will be lower than the body temperature, and if it is hot water, it will be higher than the body temperature. Just make a guess. All of you have done it? All of you have guessed and written a temperature?
Yes.
Okay. Now come to the second beaker. Now all of you come to the second beaker. All of you, what you all have taken in the second beaker?
Hot.
Hot water. Okay. So now you all try to guess what can be the temperature of this. It should be higher than the human body temperature. So you all guess and write. Okay. You all can guess and write it on the paper. Okay. You all can guess and write it on. Are you all measuring it or are you all guessing it? I'm telling you just to guess.
I'm not measuring it.
Okay, you'll guess and write it down on the paper that you brought. Okay. And the normal water will be close to the normal body temperature. Guess that also. Guess and write. You'll have to write 3 temperatures. One is of the cold water, one is of the hot water, and one is of the normal water. Okay. Have you all done it? Has everyone done it?
Yes, ma'am.
All of you, have you all finished?
Yes.
Yes. Okay. Now take your digital thermometer.
Okay.
You all will not put it into the hot water, the digital thermometer. You all will not put it into the hot water. You all can try it with the normal water and with the cold water.
Cold water.
Okay, it is not very cold. Have you all brought it from the fridge? Is it chilling cold?
No.
No. Okay, fine. Then you all can try in both the beakers. You all, again I repeat, you all must not try it with hot water. You all must not use the digital thermometer with the hot water. You all try using the thermometer with the cold water and the normal water. Okay. When you all find out the temperature, write it below the temperature that you all have guessed. When you all have measured the temperature, write it below the temperature that you all have guessed.
Ma'am, my thermometer is not measuring it.
Okay. You all are waiting for some time or not till the beep sound comes?
Yes.
Do not take very hot or very cold water. Do not test it with hot water. Do not test it with very cold water. You all can test it with, you all should not test it with chilling cold water, okay?
Okay.
You all can test it with the normal water and with the slightly cold water.
Ma'am,
Yeah.
90.
If you all are done, then you all, okay. If you all are done, then you all can let me know.
90.4.
What is 90.4?
The temperature.
Of what? Hot, of cold water or normal water?
Normal water.
It is 90.4.
90.4.
Okay. Has anyone else measured 90.4 degree Fahrenheit? Has anyone else measured the temperature of the normal water?
Ma'am.
Auntie, it's not 2.4 degrees Celsius.
Ma'am, my thermometer. Ma'am,
Yes,
my
yes.
thermometer is not measuring the water.
Try to measure the water with normal temperature.
Okay.
I actually have a digital thermometer, but
Okay.
it's showing L and it's showing L when I dip it in cold water.
So you don't use
Okay,
it
then
for cold water. Use it for the normal water, the normal temperature water.
Even normal is showing L. It's showing LO of cold water.
Okay, that means it is below the range.
okay, it must be very cold then. Okay.
Oh, okay.
Then you'll measure the normal water then. You all can measure the normal water and tell me.
Okay.
Okay? Yeah.
Mine is low point Fahrenheit for normal water.
How much? What is the temperature?
Low point Fahrenheit. LO.
For normal water.
Normal water is
Yes.
also showing LO.
Ma'am, my
Ma'am, even mine is showing yellow.
The normal water is 96.4 Fahrenheit.
ma'am, the
Okay.
cold water is low
For those
Fahrenheit.
whom normal water is showing LO, try to add little bit of hot water into your normal water and then try to measure. Little bit of hot water into it.
Yeah, it must be very cold, which cannot be measured by the digital thermometer then. Very little, okay? Not much, very little.
Ma'am, it is still showing yellow.
Yes, ma'am.
No, ma'am. Only yellow.
Yes.
Is it showing yellow for everyone?
No.
No, ma'am. Now it is coming.
What is coming?
95.4.
Very good.
Okay,
Very good.
95.4. Okay, fine.
So for those for whom it is LO, keep adding little bit of hot water and try to do it again. Switch the thermometer off, put it on again, and then try to measure it.
Ma'am, still coming yellow. Low.
But you had got no, Angela, you had got 94 now or 96 something.
Ma'am, my thermometer is not working.
Okay. All right. So this is the reason why we wanted you all to have a clinical thermometer. Okay. This is how you measure the temperature. Whenever you all have a clinical thermometer at home, you all try to do the same activity. Okay. Try to measure, try to guess the temperature and measure it using the thermometer. Okay, try to do this activity once you have a normal analog clinical thermometer.
Okay.
Okay, Nicola, we move on to the next slide. Yeah?
Okay, fine. Okay. Now, do you all know or have you heard about cold-blooded animals? Has anyone heard about it?
Yes, ma'am.
Okay, can you tell me what is the meaning of a cold-blooded animal?
They can adapt from the climate.
Okay, they can change their temperature according to the climate. If the temperature out is very hot, okay, if it is hot outside, their body temperature will rise, and if it is cold outside, their body temperature will deteriorate, or it will fall. Okay,
Okay.
so cold-blooded animals are the animals that can change their body temperature according to their surrounding temperature. If the surrounding temperature is high, their body temperature will also become high. If the surrounding temperature is low, their body temperature will also become low. Okay?
Okay.
Frogs, snakes, crocodiles, all of them can change their body temperature according to the outer surrounding temperature. All right? Now, warm-blooded animals are the animals that cannot change their body temperature. Whatever may be the temperature outside, it doesn't matter. Okay? If it is cold or hot outside, warm-blooded animals, they maintain a constant body temperature. Their body temperature has to be fixed. It has to be constant. It cannot vary with the surrounding temperature. Okay? We are also coming under warm-blooded animals. We also cannot change our temperature according to the outer temperature, according to the surrounding temperature.
Yes, ma'am.
All right? We have a fixed body temperature. What is the body temperature?
37 degrees.
37 degrees Celsius, or what Fahrenheit? What degree Fahrenheit? What degree
98.
Fahrenheit?
98.
8 point what? It is not exactly 98. It is 98 point something.
6.
6. Okay, very good. So it is 98.6 degree Fahrenheit. Okay. Now see. Now you'll also have to do this activity. Okay. You will be given a sheet. Okay. In that sheet, from Monday to Sunday, you'll have to color this thermometer according to the temperature. Now, from where will you all get the temperature? Do you all know? From where can you all know the temperature of the day? How can you all know the temperature of a day? You can either get it out from the newspaper, you can watch the news channel and get the weather report of that day, what is the temperature of that day, or you can also get it from your parents' mobile phones. Okay.
Okay.
Yeah, whenever you from the mobile phone also you can get what is the temperature of the day.
Okay, but
So from any, yeah, so,
but it's it is 37.7 degrees Celsius.
what the normal water temperature?
Worksheet.
I couldn't hear you.
Worksheet. The worksheet.
The worksheet is today's temperature. Are you telling me today's temperature?
No, the diagram in the worksheet is only 37.7 degrees Celsius.
Okay, it is only till 37.7 degrees Celsius. Okay. So you all will, yeah, it might not rise above that. Okay. That's why it is only mentioned till that temperature. So you all try to record it. Yeah.
Here in Delhi, it is 38.2 degrees Celsius.
In
Here in Delhi, it is 38.2 Celsius.
okay.
So
Okay.
Jigisha, you can draw a similar thermometer near that in the activity sheet, and you can add on more temperature, like you can go on up till 38, 39, and you can color it accordingly. Okay. For those who's for right now we have students from different cities. Okay. The average temperature right now everywhere will be something between 32 to 35, 36, but some places can be really hot. Okay. So for those people, you can draw a thermometer on the same activity sheet and you can color it as per the
Okay.
temperature in your area.
Okay.
Okay.
Okay. So I'll be asking you all some questions now. Okay? Are you all ready to answer them?
Yes.
Yes. All of you all can put your microphones on. Okay? Yeah. I'll be asking, and all of you all should not answer together. Okay? If someone is answering, you all can keep quiet. Okay. Name an instrument used to measure temperature.
Thermometer. Thermometer.
Thermometer. Very good.
Thermometer. Thermometer.
Okay. Okay. Name the liquid that is used in a clinical thermometer.
Mercury.
Mercury.
Mercury. Very good.
Mercury.
Okay. Now, why do we jerk the clinical thermometer before use? Why do we need to jerk it?
That the mercury goes below 35 degrees Celsius.
Okay, very good, very good. Okay. Now, what is the role of the kink in the clinical thermometer? What is the role of the kink in the clinical thermometer?
So that it blocks the mercury. It stops the mercury to fall down.
Yes, very good, very good. Okay, all of you have understood very well. Okay,
Yes.
why should we wash a clinical thermometer with an antiseptic solution before use?
So that
So all the germs get out.
Okay, so that all the germs are killed.
get out.
Yeah, yeah. Okay, tell me, why is the range of the clinical thermometer so low? Why is it so low?
Because the body temperature on the
Yeah, because it is only meant to measure the body temperature. Okay, so you have been very good in answering all the questions. Okay, do you all have any more doubts regarding this topic? You all can ask me any question if you all have any doubt regarding today's topic. Do you all have any doubts?
No, ma'am.
No, ma'am.
No, ma'am.
You all want to clap for yourselves. You all did a good job now today. Learned measuring temperature. So let's clap for ourselves. Come on, children.
Yeah, you all can clap for yourselves. You all have done a great job. Okay, you all were able to answer